Hello and welcome back to my GCSE Science. In this next video about acids, we're going to be talking about the pH scale and neutralisation. The pH scale is a really important idea in chemistry. You'll have seen it in your labs, I'm sure, and you probably did some experiments on acids and alkalis when you were in year 7 or 8. So let's have a look at it in more detail. First of all, we need to know what the definition of an acid is. You may know that acids turn the universal indicator red, but you may not know that the definition of an acid is that it dissolves in water to produce hydrogen ions, or H+ ions. So this would be a general equation to show an acid breaking down or dissociating to form a hydrogen ion and leaving behind a negative ion from the acid. More specific examples of this equation would be, for example, hydrochloric acid. When it dissolves in water, it breaks apart into a hydrogen ion and a chloride ion. Sulfuric acid, because it's H2SO4, breaks up into 2 hydrogen ions and a sulfate ion. Phosphoric acid is an unusual one, but it could come up in your exams. And because it's H3PO4, this means that it releases 3 hydrogen ions and 1 phosphate ion when it dissolves in water. So all acids will release H+ ions or hydrogen ions when they dissolve in water. So an alkali is the opposite. An alkali dissolves in water to produce hydroxide ions, OH- ions. So this would be a general equation for an alkali dissolving in water. M stands for the metal, and OH is the hydroxide ion. So it breaks down into a positive metal ion and the negative hydroxide ion. Examples of this using some common alkalis would be, for example, sodium hydroxide, breaking down into sodium ions and hydroxide ions when they dissolve in water. Calcium hydroxide has a slightly different formula because calcium is in group 2, and so it has a 2+ charge. Because a hydroxide ion has a 1- charge, we need 2 hydroxide ions for every 1 calcium ion. So when calcium hydroxide dissolves in water, we get a calcium 2+ ion and 2 hydroxide ions. Finally, another important alkali that you need to be aware of is ammonia. It's naturally found as a gas, but when it's dissolved in water, it forms the ammonium ion, which is NH4+, and the hydroxide ion. So any substance that dissolves in water to produce a hydroxide ion is an alkali. This is the pH scale. The pH scale. pH is a measure of how acidic or alkaline a substance is, because they won't all release the same amount of H+ ions or OH- ions. If the substance has a pH of less than 7, we say it is acidic, and if it has a pH of greater than 7, we say that it is alkaline. pH 7 is neutral. The further away from 7, the stronger the acid or the alkali. There are 2 ways to get a measurement of pH across the full scale. The first is to use universal indicator, which gives you a pH measurement based on the colour shown in this chart. And the second is to use a pH probe, which is a digital device that you put into your beaker, and it gives you a reading in numbers. A neutralisation reaction is when an acid and an alkali react. The hydrogen ions in an acid react with the hydroxide ions in the alkali to produce water. So this equation here is the standard equation for neutralisation. No matter which acid you've got or which alkali you've got, the neutralisation equation is always the same. This type of equation is called an ionic equation because it just shows the ions that are involved in the reaction. Here's an example of a neutralisation reaction. We've got hydrochloric acid and sodium hydroxide reacting to make the salt sodium chloride and water. So we have the H+ and OH- ions reacting to make water, and the chloride and sodium ions get left behind as sodium chloride solution. Sulfuric acid reacts in the same way, and in this case it reacts with potassium hydroxide to make potassium sulfate and water. But because there's 2 hydrogen ions in sulfuric acid, we need to balance the equation slightly differently. Always keep an eye on the charge of all the ions involved to make sure that your formulae are correct and you get the correct balanced equation. Here's a summary of the keywords we looked at today. Thank you for watching, and I hope to see you again soon on another video by My GCSE Science.